Hello, everyone. I hope that you can hear me clearly. Just write in the comments if you can just hear me clearly and the audio is okay and good. So I'm just waiting for one of the comments to pop up. All right. So my name is Arshan Anwar. I'm the co-manager of GDG Cloud Islamabad. GDG Cloud Islamabad is a community of developers that actually help each other in utilizing the technologies that Google offers on its own cloud platform and to develop the amazing things that can actually help people in the long run. And this session is one of the many sessions that we have been doing to bring the developers together in these times in which everybody is working from home and actually very unprecedented times. So without any further ado, let me introduce Aksa Kausar. Aksa Kausar is one of Pakistan's first GD in ML machine learning, and she has been doing some amazing work with Red Buffer. It's an organization that works in artificial intelligence and machine learning platforms as well. So let me add Aksa right now. Hi, Aksa, can you hear me? Your mic is muted.
Yes, I can hear you.
Okay. So, Aksa, if you can kindly share your slides, and then I would leave the stream to you.
They're shared.
I can't see them on the studio. Can you share them again?
Yeah,
Share
sure.
the screen, I think. All right. Let me see. Yeah. Can you see your slides, Aksa?
Yes, I'm here, but I don't think they're yet visible
Can you
on
see
the
your
live stream.
slides?
Yes, I can see them.
Okay. No, you're audible on the live stream because you have been added here. Okay. So I will hand over the session to you, and you can now start. So let me remove myself from the screen, and here you go, everybody. Aksa Kausar.
Assalamualaikum, everyone. I'm here today to give an overview of the concept of explainable AI and how that can be used in Google Cloud, what explainable AI is, and how do we unravel the black box. So, about me, I'm a machine learning engineer at Redbuffer. I've been working there for about roughly 1.5 years. I'm also a Google developer expert in machine learning. And side by side, I write blogs on Medium on AI and ML and the different concepts related to it. Today's session will be about what is explainability, why is it important, where does it exactly fit in the machine learning workflow, and given the amount of time, I'll try to give a small demo of how it works in a notebook or what you should be expecting for it to look like in a notebook. So with time, as we have more computational resources, as we have more data set and larger data sizes, we have been building more complex non-linear models. So we have seen this progression from handcrafted rules and heuristics to linear models and decision trees, ensembles and deep models, and then to most recently something that we call meta learning, which is where models create other models. So with this progress, we have seen that there has been more expressiveness. By expressiveness, I mean to say that the models can look at now a wide range of domains. So you have forecasting, you have autonomous driving, you have drug discovery. The models have become more versatile. By that I mean that we have unlocked more new data modalities. So we have image, audio, we have speech, text, tabular, time series, and we also have like joint multimodal applications where you have speech and text, or you have audio and image, etc. So with this new paradigm shift along multiple dimensions, we've also had this adaptability where now the models are more adaptable, because with transfer learning, we can now deal with smaller data sets as well. And we have also become more efficient. And by efficiency, I mean now we have like more custom optimized hardware solutions like GPUs and TPUs, which the practitioners can use to train bigger and faster and cheaper models. But on the flip side, with these more complex models, have become in these complex models have become increasingly opaque. So we're it has become harder for us to understand how these models are working, why they are predicting what they are predicting. We've lost control of how we want to debug these models for specific kinds of problems that we are facing in the models. We have undesirable data amplifications. We have this loss of debuggability and transparency. And that's where exactly explainable AI sort of jumps in. So, explainable AI has been expressed as the ability to explain or to present in understandable terms to a human. So when we say explainability in simpler terms, we mean to say the process of understanding how and why a machine learning model is making predictions. Why is it making the predictions that it is making? Why not? Why call something a cat? Why is it calling a certain picture a cat? Why is it calling a certain picture a dog? What are the features, or what is it looking at in the image to be able to make that prediction? So, and this concept of explainable AI is useful for people at both ends of the machine learning workflow. So, it is useful and important for model builders as well, because they want to be able to understand whether the model is doing right or not, and they want to be able to improve the performance of the model and understand the model better. At the same time, it is also important for model end users who want to build trust in the models, who want to, because they do not understand the technicalities around machine learning and how it really works and how the model works. They're only looking at the end result. They want to understand how and why this happened, or how and why this was predicted. So this is important for both ends of the machine learning workflow, for both ends. And before we dive in further, let's see how explainability looks like for different data modalities. So starting off with image models. So you can see that for image model, this is what it would look like. So for example, I have a model that I'm using to classify different types of animals, right? And I want to understand how my model is performing. So explainability for image models would basically give you the pixels which signal most to a particular model prediction. So for example, in this case, if it's called a bird, so the explanation, you can see the highlighted pixels, and they're highlighting the beak and overall kind of like the shape of the bird. And this is giving the prediction of which bird this is. So these are the pixels which are basically signaling to the model prediction for this particular image. And similarly, for the second one, you can see that the highest signals are around the eyes, right? And somewhat the boundary or the shape of the animal. So you can sort of see that how what your model saw in the picture to be able to signal to that model prediction. Now, why would this be important at this point? For example, if the highlighted pixels were at the background and not really at the beak of the bird or around the shape of the bird, so you'd know and understand that your model is not learning the feature that it needs to learn. It is not understanding the images right, and it's not. And this could really help you debug the problem in your models. That okay, it is not picking the right features in images of birds, but it's doing well for other animals, or vice versa. And on the other hand, if it is performing well, you'll be able to understand, okay, your model is giving the expected results. It is giving the right results that you are expecting. So what would this look like for text data? So for example, here we have two examples. Looking at the first one, the predicted label is action. Now you can see these blue words here. These are the ones that are giving the highest signal for the predictions. So these are the words like mission, learn, skill, and this really gives you an insight into, especially with text, because text models are harder to understand in comparison to images models, because it's harder to understand which areas of the text or which words basically led to the prediction. And explainable AI in this case gives you this insight into, okay, these are the words that signaled the most or gave the highest signal for the, or contributed the most in the prediction that you got, which is the label action. Similarly, for text models, explainable AI can be used to remove biasness in identity, for example. So identity is basically something that is used to identify something specific, right? So for example, if I'm trying to train a model and I want to classify different sentences as positive and negative, and I have two sentences. One of them says, I like Liverpool, and the other one says, I like FC Barcelona. Now, I would want the model to predict both of them as positive. And not just that, I would want the model to give equal weightage to both Liverpool and FC Barcelona in contribution to that positivity, right? I would not want my model to be biased towards one of those, because in more complex cases, this leads to greater biasness in your text, right? So if I'm getting a negative result for I like FC Barcelona, then that sort of suggests that I have my model is biased towards Liverpool. Or if I'm getting a less positive result for FC Barcelona, that also suggests that my model, given that all the other words are the same, is biased towards Liverpool. So these are some of the biasness that you can have an insight to if you use explainable AI and you fit that in your machine learning workflow. So moving on, for tabular data, this is what it would look like. So I have a data set and I'm trying to predict the duration of bike duration. And that is what I'm trying to predict, that how long was the bike ride. And I have all of these different features, which are rain, drizzle, maximum temperature, weekday, start hour, etc., etc. So for looking at this chart, you have attribution values for each of these features. Going forward, I'll explain this a bit more, what they stand for here. But right now, let's go a little simpler. So attribution values, I have attribution values for each of these features. And I can see that maximum temperature contributed most. Since the attribution value is negative, I can also see that maximum temperature contributed most in reducing the bike duration for most of my sample data sets. So it contributed most in reducing the bike duration. And similarly, for other cases, features, you can see how they performed or how much they contributed negatively or positively to bike duration. So why is explainability important to model end users? So looking at one of the examples for that, so taking the example on the top left, which is basically a retina image. So a model was trained on different retina images in order to classify the retina images under the disease of diabetic retinopathy. So diabetic retinopathy is a disease that occurs in diabetic patients, and it has different stages of severity. So the model was trained in order to classify different retina images as on the level of severity of the disease. So it could be low level, it could be mild, or it could be high severity, right? So then the model was used obviously for predicting. And as you can see, this is what explainable AI would look like for when a doctor would want to see how wide a mild was predicted in this case. So this predicted mild. And if a doctor wants to see why mild was predicted in this case, these are the regions, the highlighted green regions, which basically contributed to the model prediction. So the doctor can use this to verify and to diagnose and also to build their trust in the model. So that the model is not just giving out a prediction, okay, this is what I think, but the model is also trying to explain why is this what I predicted? Why did I predict mild in this case? So this has huge use cases, huge number of use cases, especially in cases where the trust in model is very crucial. For example, in the cases of medicine, but it can also be used in other cases. So for example, in recommender systems, to be able to tell you why are you getting a certain prediction. Okay, this is why you're getting a certain prediction because you have watched 1, 2, 3, 4 these movies recently, etc. At the same time, we have models where mostly what we look at is just accuracy, and we try to use accuracy as a measure of model performance and put most of our trust in how accurate the model is to define how well it is performing, right? So for example, here the model accuracy is 99.3%, but that is only just one piece of the model evaluation. You're getting a certain model accuracy, but is that it? Is that all you need to know about your model? Is that all you need to know to be able to trust how well your model is doing? So this is where explainable AI is basically the second connecting piece. And it tells you not just how well your model is performing, but also why is it performing the way it is performing. So for example, there was a case of model biasness where there were images of X-rays and they were the model was basically used to predict, to diagnose using those X-ray images, and the model was performing really well. Now the accuracy was high, but when they looked into explainable AI, they figured that the model was not looking at the X-ray image itself. It was also looking at the doctor annotations on the X-ray. And it was biased towards those annotations and basically using those instead of the X-ray itself. So these are some of the buggy behaviors that you can look into or understand or figure out when you combine the second piece of explainable AI with your models. So explainability, as I mentioned earlier, is important to both model builders and model end users. It can be used to identify biases in the model behavior, like this can be reflected back to the text example that I shared. It can be used to understand how the data set influences model output. You can use the different kinds. If your data set combines of different kinds of data, you can sample these different kinds, pass them through your model predictions and see how the model performs for each of those data, right? For each of those data, which maybe come from 5 different regions or 5 different types, depending on your problem set, right? And you can see how your model is performing to these different groups of data which combine to form your data set. So at the same time, you can also use it to improve your model performance. For the model end users, obviously this can be used to, explainable AI can be used not only to get an overall picture of how your model is performing and the feature attributions, but also to get insight into each instance of your sample data and how the attribution values for features for a single data point can also be, there are tools to do that as well in explainable AI on GCP. And to be able to understand model behavior as a whole. This would also help for cases where you want to explain your model to your clients or to your stakeholders, and giving them accuracy or metrics or predictions or results, showing them results is one thing, but at times you want to tell them more, they want to know more about how your model is working. And explainable AI can be used in that case as well to be able to help you develop trust with your clients, with your stakeholders, and for you to understand your model better. So how does explainability fit into the machine learning cycle? Now, the normal machine learning cycle, as we know it in its simplest form, is to gather and pre-process data, to build model, to run training and evaluation, to deploy the model, and to make predictions. Explainable AI is not something that that's like a one-time thing. It is actually, it can fit into a number of places in the path of your machine learning lifecycle, and it's an iterative process. So you can use it to identify dataset imbalances. There are tools in Explainable AI that help you do that. At the same time, you can use it once you're done training and evaluation, you can use it to ensure that your model is treating all groups fairly. The same example that I told you, that if you have, for example, data set that you're collecting for a problem, or for example, for Corona, right, you're collecting data set from the 4 provinces of Pakistan, and you want to be able to understand that if your model is biased towards any region, right? So you could use samples from these different 4 regions, pass them, look through Explainable AI, and identify if there's any biasness towards any of those regions in the predictions of the model. You can also set prediction thresholds. So for prediction thresholds, this is, for example, if I'm detecting, if I have a cat and dog classifier, and I want my classifier, if it says by 80% confidence that it is a cat, I want it to say, okay, yes, this is a cat, right? So 80% or above is fine for me in that case. But if it is a medical problem and I'm doing some medical diagnosis, and I'm trying to diagnose this disease, in that case, I want the model to say, to give a yes prediction only when it is 99% confident. So this is here 99 and 80 are basically your prediction thresholds, which you can set, and your model can perform accordingly. You can also use Explainable AI once your model is deployed to understand model behavior on real data. Because for training, we always have a data set that we clean really well, that we pre-process, that usually comes from a limited sources. And then once the model is built, it performs really differently on real data, and we're not always sure of why that difference is there. So Explainable AI can be used in order to understand why your model is performing the way it is performing on the real data, and to the level of each data point. So you can understand this to the level of each data point, that why did your model give a certain prediction for a certain data point. And then you can use these not just to just for your own understanding of the model, but also for the end users, whether that be doctors or other people or stakeholders or clients, whoever it be, to be able to see how and why the model is performing the way it's performing. This is just combining all of the 5 steps here in an iterative cycle, because as you get more data, you'd want to go through this, you can go through this process again, and you can improve your model performance with time. Now coming to Google Cloud Platform. So Google Cloud Platform has a lot of products for machine learning, from ML APIs to BigQuery machine learning to AI platform to machine learning frameworks. Now, Explainable AI tool is basically can be integrated in different products on Google Cloud Platform for ML explainability. It is expanding, and currently it's not available to be integrated in all parts of Google Cloud Platform, but right now it can be integrated used with AutoML and AI platform. So AutoML is basically where you do not really need a model. It's and you can just upload your data, train with a click. So this AutoML is basically, which includes all of Google Vision APIs, the text, NLP, Vision, AutoML tables, etc. So currently, Explainable AI is available with AutoML tables, and on AI platform, where you can basically train your models, you can serve your models for predictions, manage your models. Their Explainable AI is available for models which are built on using TensorFlow. But this is going, initially there was just TensorFlow 1, which was supported, but now they also have support for TensorFlow 2. And they are adding more and more features with time. So Explainable AI will be growing in GCP as we see it. So in a summary, Explainable AI can be used to explain why an individual data point received a prediction, to debug odd behaviors, to improve model performance, to verify if the model is doing as expected, and to present a summary of the model. Looking at explanations on how it would look like in AutoML tables. So in AutoML tables, you basically have this, it gives you, Explainable AI gives you a global feature importance. So global feature importance would look like as it looked like here. So you can see that Euclidean had the highest feature importance and it was contributing the most to predictions. So for those of you who do not know about AutoML tables, you can think of it as the name suggests, it's tables and you can predict for different columns. So the UI similarly looks like a table on GCP, and you can define which column you want to predict for, and it does the prediction for you. You don't have to write a model code, and this is like a quick just upload and train tool that you can use on GCP. So it gives you an overall global feature importance, and at the same time, it also gives you importance for one instance level. So the picture that you see down here, this is only for one data point. So you have the features listed here, you have the data types, you have the values of each of these features as they were in the data. So the day of the week, which day of the week this was, what was the value of Euclidean, what was the flag score. These were the values of this data point. And then here you can see local feature importance. So it gives you feature importance in the prediction for the prediction of this particular data point. So you can see that this Euclidean contributed positively, which means that this was the data for bike duration. So this contributed positively to the bike duration, which means that it contributed to increasing the duration of the bike. And this contributed, this is an important feature, maybe more important than this one, for this particular data point, and it contributed negatively. So for one local data point, you can see how each of the features have contributed. There's another tool which is called the what if tool, and that can be used. If those are used, you can basically also, and here you can also do this, you can change these values and then predict and see how the prediction changes. So I can maybe change the day of the week and see what prediction would I get for this data point, or change the Euclidean value and see what prediction would I get for this data point now. So you can play around with those things as well in order to understand better how different features are contributing to the predictions. You get this available in both UI and as an API. As an API, obviously you will get you can get a JSON return with the feature attribution values for each data points. So for explanations on AI platform, this is how it would look. So for example, if I am trying to predict the kind of flowers I have in the data set, so here it has given a prediction for the flower. And you can also see these highlighted pixels. So these are the pixels that contributed the most in this model prediction, that contributed the most for the model to be able to say, okay, which flower is this? So by default, you basically get the top 60% of the pixels that contributed to the model prediction. And this can, your models can be deployed on AI platform. You can get predictions through the prediction API as well, the explanations through the prediction API, I mean. And you can also integrate it with what if tool. So I'll talk about what if tool in a bit. But on AI platform, the workflow is what you can see on the slide here. So you basically simply build an image, text, or tabular model in TensorFlow. You deploy that model on to your AI platform, and then you perform predictions. So you can perform get predictions directly from the AI platform prediction API alongside the explanations, or you can use the what if tool and debug explanations through the what if tool in a notebook. There are different methods which are used to understand explainability in a model. And the two methods that are currently being used in explainable AI in Google, that is provided by Google Cloud, is integrated gradients and sample shaping. So the frameworks that are supported are TensorFlow. Integrated gradients is basically used for differentiable models. So for ensemble models, you'd want to use sample shapely or other methods, but integrated gradients, it can be used for tabular, image, or text, wherever the model is differentiable. And sample shapely is used for tabular data. There are other methods that are also coming along, and new features that are coming into explainable AI for GCP, and with time it's growing. For all you have to do to add explanations alongside your model predictions is to, this is as simple as that. So you have an export path where your model is present. You create the explanation method that you want, and you create this version, you add this to your AI platform, and getting explanation is as simple as this. So you can also do this through the prediction API, but this is how you can do it through your notebooks or console. So a small demo that I show in these slides. So building a tabular model for predicting byte precision. So for example, if I have a given data on byte trip, so my features are start time, day of the week, distance, weather data, etc., etc. And what I want to predict is the trip duration. Now, the dataset for this was gathered from two sources of BigQuery public dataset programs, London Bike Share and NOAA Weather. And this is how one data point looked like. So the features are here. You can see that they start hour, weekday, distance, temperature, maximum temperature, precipitation, rain drizzle, and you have the values for each of these features. And what we want to predict is the duration in minutes. So for example, for this data point, it took 11 minutes. So preparing the model for explanations, there are a few additional things that you need in your storage bucket, including explanation metadata.json, which is basically a small JSON that where you kind of has a few values. And this is basically where you tell the model the input and the output for your explainable AI. So if you want the output, you want to understand the predictions for the last layer, that's your last layer. So this is metadata.json is where you're entering all of these additional information. Then you have your saved model, and this is how the JSON looks like for explanations. JSON looks like for tabular data. So you have a baseline score, you have your output, and you have the data for the attributions. So explaining that a little further, hopefully this will make it a little simpler. So you have your features, feature names, you have the feature values, and then you have attribution values. So your attributions are always relative to the model baseline. Now, what baseline means, I'll tell in just a minute. But your model, your feature attribution values are always with respect to the model's baseline. So the negative attribution basically means that that this particular feature is basically pushing down the prediction, and a prediction is duration. So this is pushing down the duration. And the positive attribution value would mean that this feature is pushing up the duration. So here, negative 2.4 basically means that the feature distance is pushing down duration. It causes the duration for that particular, for bike it causes bike durations to go down. And similarly, for something that's positive, it causes, that would mean that particular feature caused the bike duration to go up for that particular data point with respect to the baseline prediction. So the baseline prediction is set, and these attribution values can be seen as pushing this duration baseline prediction up and down and giving you the final prediction. So when we say negative 2.4, so we mean that distance pushed the duration down negative 2.4, and startup pushed it down by this factor, right? And in when you compare them with each other, you can understand the importance for each of these feature attributions, feature values, with respect to each other. So distance contributed more to pushing the duration down as compared to the start hour or the precipitation, and similarly for other feature values. So a quick note on baselines. Just a second. So attribution values, we have seen that they're either positive or negative, but what are they really relative to, right? So they're relative to your model's baseline. So normally when we want what do we want explainable AI to do? We want it to tell us why did X happen, right? So what could X be in this case? So X could be, okay, why did the model say this is a cat? Or why did I get rejected from this loan? Or why did this transaction get flagged as fraud? We want explainable AI to answer all of these. So explainable AI would answer what you can see right here on the screen. Why did X happen instead of Y? And here Y is your baseline. So for example, baselines can be both uninformative versus informative. There's no like better than the other approach here, but uninformative is usually used in images and informative is used in, for example, tables, tabular data, etc. So instead of saying why did this transaction get flagged as fraud, explainable AI would explain to you why did this transaction get flagged as fraud instead of non-fraudulent. In case of non-fraudulent, so what would my baseline be in this case? So what I would do is if I have a data and I have these data points for both fraud and non-fraud transactions, I'd pick the ones, filter the ones which are non-fraudulent, and I would maybe take their average or take their median and use that as my baseline. So this is what baseline, the concept of baseline basically is in explainable AI, because you want to be able to, the explainable AI will basically be able to compare all of the predictions with respect to that baseline then. For images, it's usually a black or white picture or a random picture. So it could be, you could use like np.random as your baseline, or you could use a completely white or a completely black picture. But in cases where you have a lot of black and white pixels in your data set, you would want to use np.random and not just a black and white, because then you'll be creating biasness in your model on the baseline. Now there's another tool in explainable AI, which is the what if tool. This can be integrated very easily with Jupyter and notebooks, and you just have to pip install the what if tool widget. What this does is it helps you basically compare models and to compare the predictions that you're getting for each data point. So for example, here you can see these are the features and these are the values for this feature, and you can compare two models together in this tool, and you can compare 2 points together, right? You can click on the 2 points and you can compare the 2 points together, and you can see how the values for the two compare here, and how changing any of those values would affect the prediction for one of those 2 points or both of those 2 points. At the same time, you can also compare how two models are performing on the same data set. You can also see partial dependency plots. So that's right here. You can see partial dependency plots along different features. You can compare, currently you can only compare two models, but they'll probably have more coming. You can change values for a particular data point and see how the prediction changes for that data point. And all of this you can do in your notebook very, very easily. So What If tool is available on, like I said, many platforms. It can be used in Google Colab. It can be used in AI platform notebooks. It can also be used in your Jupyter notebooks. You can explore using this What If tool. You can explore partial dependence plots. You can explore whether or not your model is biased towards some data points, or you can understand how it's performing on outliers and why it is performing the way it's performing on outliers. You can visualize model performance. You can compare two models, and you can get data set summaries. You can also use the What If tool and have it integrated with your AI explanations. And in that case, you get an additional extra feature, which is the attribution value. So you would not just get the features and the values and the plot for each of the data points, but you'll also be able to see the importance, feature importance for different data points. So let's look at how AI explanations look like for images. So for example, uh, so explanations return the top 60% of the pixels that signal to your model's prediction, but you can also alter it to say, okay, I want to see the top 10% of the pixels that contributed the most, or I want to see the top 15% of the pixels that contributed the most in the model prediction. You can also use this to Explainable AI to debug your models. In that case, for example, for this, we should ideally, it should look at the shape of the flower, which it is doing. And ideally, it should look at this feature of the flower, which it is doing. So you can use this to Explainable AI to understand whether your model, and to ensure whether your model is picking up the right features, whether it is picking up the right shapes, or um, and the right colors. So you can basically use it to debug and understand your model behavior. To summarize this, I've already told before, to summarize, this is what Explainable AI does. All right. So let me give you a small demo of how this looks like in a notebook. So here we got our direct predictions without any explanations from the model. So this was the tulip with the confidence score. There's Daisy with 80% confidence, and then there's this one. With explanations, this looks like, as you can see here. So I only ran this model for 30 epochs. If it was run for maybe 60 or 90, it'll give much better prediction. Currently, it's the model 70% accurate. So you can see that it's picking up these shapes of the flowers, and here it's picking up the central area of the flower as well. So you can use Explainable AI to understand how your model is performing. And the What If tool looks like this, as you can see. So this is a data set basically, and a model to understand whether or not a sentence is toxic. So that's what the model predictions are on. Even though it does not have too many features, so you only have the comment and the comment length, but you can pick on, see different data points. You can compare two data points as well. You can choose which model prediction you want to look at. You can compare. You can have different things on the x and y's, and then compare accordingly. So these are the two small demos around Explainable AI. I would want to do a hands-on on this if more people are interested, but that's a matter of whether or not more people are interested in this. If you have any questions, please feel free to drop them in the comments. and I would like to address them. But that's about it for now.
Thank you very much, Aksa, for this great interactive session. Let me actually put a feedback form in the comments that actually has got a uh, link to actually poll that you can fill out that if you would like to have a interactive session or not. So just give me a minute. I will be posting it in the comments. So
Okay.
there is
So
one
there's a
comment. Aksa,
question.
are you willing to take the questions right now?
Yes. So how can
Aksa,
we get
you there?
explainable? Sorry, can you hear me?
Just a second. Just a second.
Sure.
Yeah, sorry, my mic was mute on this side. So, Aksa, are you willing to take the questions?
Yeah, sure. I will take them.
Okay,
Uh,
so this is one question from Saad Harun. I'm just showing it on the stream as well.
okay, so how can we get explainable computer vision? So for GCP, you basically don't really have to do anything except for to call explainable AI, use the explainable AI tool. So for Google Cloud Platform, if you're deploying your model on AI platform, then you don't really have to do any of the dirty work. All you have to do is add explainable AI tool in your predictions, and what you would get as a resultant predicted image, you would basically get two versions. You'll get a normal predicted image, and then you'll get the one with the highlighted pixels. So you can use that to understand how it's performing on the images. But other than that, yes, there are methods. The methods which are used for this are basically all from public research, which is both integrated gradient and other methods. And the concept around them are a little tricky. I can share a blog post that you can look into, which should really help you understand the math behind each of the integrated gradient methods that's used for computer vision.
All right. Anybody else has got any questions?
How can you learn explainable AI? If you're interested, I definitely love to do a follow-up session. Um, Other than that, you can also look into explainable AI Google Docs. You should be able to find some notebooks that you can play around with, even though there's not much on the notebooks. There are, I think, only two that are publicly available for playing around, but you can still use them to play around with explainable AI. The one thing that you would need, however, is an account on your GCP, and you'll need a few credits to run uh, basically the models on AI platform, and you'll need some know-how of the AI platform, which isn't too difficult. If we do have a follow-up session, you'll be able to see how exactly to do that. Otherwise, they have some good explanations on their documentation of explainable AI.
Okay, so I've just shared the link. It will appear in the comments momentarily, both on Facebook and on YouTube. So kindly fill out the form. Your feedback is again valuable for us for conducting these sessions, how we can actually improve them. There's a poll specifically in this form that I have actually added. If you would like to continue and have a very detailed hands-on session regarding explainable AI, then you can even send your feedback in this form. So with this, I would like to conclude this session by formally thanking Aksa Kausar for actually giving her time to explain the explainable AI, what it is and how it works. And I hope that the audience found it beneficial, and hopefully we will be conducting more future sessions like this. So thank you again for joining us. Thank you, Aksa.
Thank
Thank
you
you for
for
the audience
hosting.
for joining us. Yes, and we will be bothering you again and again as well.
If it's
So
possible, can we
yeah,
also add a question? Uh, any questions in the feedback form as well? As in, if anyone wants to ask a question, they can use the feedback form
yeah,
to
that
kind of.
has been added. That has been
Okay,
added. So
thank you
if
for that.
anybody would like to have a question offline, they can submit it, and then we will forward the questions to you. Again, lastly, thank you very much. Thank you to the audience, and thank you to our speaker. And hopefully, this session was sort of beneficial for you. And looking forward to more sessions like this. Thank you very much, everybody.
Thank you.